Hello, this is Mrs. Sargent, and this is Lesson 2.2, Atomic Structure and Subatomic Particles. So, subatomic particles just mean that they are particles below the surface of the atom, like subfluorine is below the surface of your normal fluorine. A proton, the location of a proton is in the nucleus. The charge of protons is positive. And the mass is approximately 1 AMU. AMU stands for atomic mass unit. To calculate the number of protons is equal to the atomic number. So positive protons give the element its personality, P, P, and P. So if we take a look at our periodic table, we want to know how many protons bromine has. Bromine, the symbol for bromine is Br, and you should find that it is atomic number 35. So it has 35 protons. Electrons, the location is in the electron cloud. The charge is negative. And the mass, they do have mass because they're matter, but it is really, really, really small. So for the purposes of this class, we are going to say that the mass is approximately 0 AMUs. To determine the number of electrons, it is in a neutral atom, it is equal to the number of protons. We will talk about what happens when atoms are not neutral later on, but for right now you can consider everything a neutral atom. So how many electrons does a neutral atom of bromine have? Well, remember we said that it had 35 protons because the atomic number is 35. So it is also going to have 35 electrons since we're told that it is a neutral atom. The neutrons, the location is in the nucleus. The charge is neutral. And the symbol for neutral is a 0 with a slash through it. The mass is approximately 1 AMU. And to calculate the number of protons, you take the mass number minus the number of protons, and that will tell you the number of neutrons in an atom. So you have this diagram of an atom. I'm going to point out some shorthand for the different subatomic particles, and then we're also going to label them on our diagram of the atom. So for electrons, shorthand for electrons is a lowercase e with a negative sign, and the electrons in our diagram here are the blue dots with the negative sign. Protons, shorthand for that is a lowercase p with a plus sign, superscript, and those are our red dots with the plus sign. The neutrons, it is lowercase n with that 0 and the slash through it for shorthand. And those are green dots with no charge sign on them. And then to label our nucleus, we're just going to put a bracket around the protons and neutrons that are in the center of the atom and draw a line, and that is our nucleus. And the electron cloud is just basically anything outside of the nucleus where these electrons are located at. So I'm just going to label that even though we didn't have that on our list of things to label. So now we have our diagram of the atom labeled. So isotopes. What are isotopes? Remember that the mass number is the protons plus the neutrons. So we have carbon-12 and carbon-13. And this number after the name is the mass number. So I have these pictures that show you the protons and neutrons. The protons are the green with the smiley faces and the plus sign for the nose. So we have 1, 2, 3, 4, 5, 6 protons. And neutrons are the teal straight-faced faces. So 1, 2, 3, 4, 5, 6. 6 neutrons. Mass number is protons plus neutrons. 6 plus 6 gives us 12. And then for carbon-13, smiley faces 1, 2, 3, 4, 5, 6. 6 protons. Neutrons 1, 2, 3, 4, 5, 6, 7. 6 plus 7 gives us a mass number of 13. So the first thing I want you to notice is that the number of protons for both of these carbon atoms is exactly the same. And if you take a look at your periodic table, carbon's atomic number is 6. So carbon is always going to have 6 protons because its atomic number is always going to be 6. The difference comes in the number of neutrons, which then gives us a different mass number for both of these carbon atoms. So what is an isotope? An isotope is atoms that have of the same element with the same number of protons, but they have different number of neutrons, and therefore they have different mass numbers. So there's two different isotope notation, and this allows us to know how many neutrons is in each atom. So the first one has the symbol of the element. And if you take a look at your periodic table, find Na for sodium, you'll find that the atomic number is 11. So the number here on the bottom is the atomic number. And then this top number is our mass number. Here in our other isotope notation, when you have the name dash a number, this number is the mass number. So what's the difference between mass number and average atomic mass? Mass number, remember, it's the protons plus the neutrons. So we have 1 proton, 1 neutron, that gives us a mass of 2. The average atomic mass is the weighted average mass of all of the known isotopes. And in a few lessons, we are going to talk about how to calculate average atomic mass, but for now, you just need to know that it's the weighted average mass of all the isotopes. What I like to think about is with your grades, you have your formative work and you have your summative work. Formative is 35%, summative is 65%. And so within a grading period, they take all of your scores and weight them, average them and weight them for 35% for formative, and then all of your summative scores, weight them and average them for summative work, and together those combined make your overall grade. Your mass number is always going to be a whole number. You're never going to have half of a proton or half of a neutron. Your average atomic mass should always be a decimal number. Even if it is 16.00 for oxygen, it still has that decimal. So you have this table at the bottom of your notes page. And you're going to need your periodic table, so if you don't have that, go ahead and get that out. We want to find manganese. Manganese symbol is Mn. It's towards the center of your periodic table, and it has an atomic number of 25. And the atomic number is the number that is centered at the top above the element symbol. So then, remember, we said that this number here, the 55, is our mass number. With a symbol notation, the mass number goes on top, and the atomic number goes on the bottom. Number of protons is equal to the atomic number, so we also have 25 protons. Neutrons is the mass number minus the atomic number, so 55 minus 25 gives us 30 neutrons. And then the electrons are equal to the protons, which is also 25. So now in our next row, we're not given the name or the mass number. We're given the atomic number and the number of neutrons. So atomic number 47, find that on your periodic table. And you should find that that is silver. The symbol for silver is Ag. And we can put in our atomic number next to our symbol. Protons is equal to the atomic number, so 47. And electrons are equal to the number of protons, so 47 there. To fill in our mass number, we need the protons plus the neutrons, so 47 plus 61 is 108. And then we can fill in the mass number next to our symbol, and then behind the name. And so then for our final row, we have selenium, 79 over 34. This top number is our mass number. The bottom number is our atomic number. Atomic number is equal to the number of protons. Electrons are equal to the protons. Mass number minus the atomic number is going to give the number of neutrons. So 79 minus 34 should give us 45 neutrons. And then we said that the name of this is selenium. Mass number is 79. So your practice on page 6 is a chart very similar to this that you're just filling in and using the information given to calculate the other subatomic particles. Your quiz also has a chart like this for subatomic particles. Feel free to stop by and ask me if you have any questions. Thanks for stopping by. Have a great day.